Welcome back to All This Math. This is Professor Parker, and this is our next installment of Dirt Bike Math, where we're talking about gas-oil ratios. I've done some videos where the gas-oil ratio was 32 to 1, 32 parts gas, 1 part oil. Now I switched it up to, I believe, newer bikes, if I'm not mistaken, or some newer bikes. I think those manufactured after 2003 require less oil. So the gas oil ratio is 40 to 1, right? As opposed to 32 to 1. You know what I mean? But before I get into that, I have my Nat Turner Day Celebration t-shirt on, right? Shout out to Nat Turner, the ancestor who led a slave rebellion in the year 1831 near Southampton, Virginia. Please research Nat Turner if you're not familiar with him. The movie is cool. Birth of a Nation, that's cool. But get your real research from writings. All right, from writings. There's been a lot of writing about him. Dr. John Henry Clark edited a collection of essays about Nat Turner, and other people have written about him as well. You might also want to look into some of the other slave rebellions around the same time. Nat Turner was in 1831. Denmark Vesey in South Carolina was in 1822. And we have Gabriel Prosser, even though his plot was foiled because of snitches and rats. Gabriel Prosser was in the year 1800 in Richmond, Virginia. And there were some others as well. That's you know, they weren't the only three. I mean, we always was fighting. We always was fighting back. We always was rebelling. Don't listen to don't buy into the narratives that a lot of public schools and charter schools and private schools and mainstream media and television and movies want to give us to make us feel like we was weak and feeble and we never fought back. We always fought back, right? That was the norm. That's why we still here, because we fought back. You know what I mean? So definitely go do your research, learn, about some of these brothers and the sisters that was involved in these rebellions too, if you're not as familiar. And even if you are familiar a little bit, go get more familiar. All right. Anyway, the dirt bike math. Now, let's check out this word problem. Like I said, this is similar to a lot of the other problems that I've done already on the channel. Hopefully you're subscribed to the channel, and also hit the bell, turn on the post notifications so you can be notified when new content gets put out. All right. Also follow us on Instagram too. Follow us on Instagram. We definitely have content on Instagram as well. All right. So here's the problem. On your two-stroke bike, your gas oil ratio is, like I said, 40 to 1, right? 40 to 1. 40 parts gas for every part oil. 40 parts gas for every part oil. How much oil should you mix with 1 gallon of gas? All right, so if you got 1 gallon of gas that you're putting into your tank, right? How much oil should you mix in with that? All right, now we use a mathematical formula to figure that out. First, let's talk about a ratio. The ratio is 40 to 1. Of course, a ratio is just a fraction. That's all a ratio is. It represents a relationship between two numbers, okay? So in this case, the first number, we can think of that as our numerator. The second number, we can think of that as our denominator, all right? 40 to 1. So, but before we even start dealing with the numbers, let's talk about writing a proportion with words in it. Write a proportion with words in it. So let's talk about, since we're dealing with the gas-oil ratio, our proportion would just be gas over oil is equal to gas over oil. All right, gas over oil is equal to gas over oil. All right, now, then we're going to replace the words with numbers. That's a large part of algebra right there, just knowing what numbers or what words get replaced and with what numbers. All right, so we got gas over oil. So we're going to use this ratio to replace this word gas and this word oil in the first fraction. All right, so it's going to look like this. It's going to be like this much gas, 40 parts gas to 1 part oil. All right, then we're going to do our equal sign. Now the second fraction is going to include the unknown information, how much oil, because we don't know how much oil you should put in, right, when you got 1 gallon of gas. We're going to use math to figure out exactly to the whole number, or even to the 10th or the 100th or whatever. We're going to find out exactly how much in terms of, now we could use, we can find out how many gallons of oil we should use. We can find out how many ounces of oil, or we can find out how many milliliters. I think we should do both. I think I'm going to find out how many gallons, not both, but all three. I'm going to find out how many gallons of oil. Then I'm going to convert that to ounces. I'm going to find out how many ounces of oil. Then I'm going to convert that to the metric system. And I'm going to find out how many milliliters of oil. I'm going to show you how to do all that. All right, so we got 40 over 1 is equal to the amount of gas is 1 gallon. The amount of oil, we don't know. We'll call that X. All right, so that's our equation. 40 over 1 is equal to 1 over X. So if 40, right, matches up with 1, all right, that's 40 to 1, then we want to know how much oil matches up with this much gas. All right, how much oil matches up with this much gas. Now, since it's set up like a proportion, we're going to use something called the cross product property. The cross product property. So then as we look at diagonals, right? So 40 and X are diagonal. So we're going to multiply like that. 1 and 1 are diagonal. So we multiply like that. This is a way to simplify the equation and eliminate the fractions. So I got 40 times X, which is 40X. Right, my equal sign. Then I got 1 times 1, which is 1. And now I got 40X equals 1. So now what I want to do is I want to solve for X. I'm still trying to solve for X. This is part of the process of solving for X, but I'm going to continue that process, and I'm going to try to isolate X by itself. So I'm going to get rid of this 40. I'm going to get rid of the 40. Now the question is, how do I do that though? You do the opposite operation. So the opposite of 40X, which is 40 times X, or the opposite of multiplication is division. So we're going to divide by 40 on the left-hand side, but because it's an equation, we want to do the same thing on the left side and the right side. So we're going to divide by 40 on the right-hand side. 40 divided by 40, boom, boom, boom. That's X. That's just X. I'm going to slide horizontal. And then 1 divided by 40. 1 divided by 40. I'm going to grab my calculator for that. All right. So I got 1 divided by 40. 0.025. 0.025 gallons. This is how many gallons of oil we need when we have a 40 to 1 ratio and we have 1 gallon of gas. Now, normally we wouldn't represent that small amount of oil in terms of gallons because that's an inappropriate measurement. Like, why would we do that? That's almost like measuring the distance from Philly to Baltimore in inches. Like, you could do that, but it's more logical to measure it in terms of miles or even meters, or not even meters, kilometers, miles or kilometers. Because if you measure the distance from Philly to Baltimore in terms of inches, that number is going to be humongous when it don't have to be, right? So we want a unit of measurement that makes sense, all right? So we wouldn't measure this small amount of oil in gallons, all right? We would convert it to ounces or maybe milliliters, all right? Which I'm gonna do both. I'm gonna show you how to do both. So in order to convert this many gallons to ounces, I'm gonna set up another proportion. And of course, a proportion is just 2 ratios set equal to each other. 2 ratios set equal to each other. Except in this proportion, it's gonna deal with gallons and ounces, gallons and ounces. So gallons over ounces is equal to gallons over ounces, right? Because there's a relationship between gallons and ounces. So first we start out with the words. Gallons over ounces is equal to gallons over ounces, right? So first question is, how many gallons, or actually I should say this, 1 gallon is equal to how many ounces? That's the question. 1 gallon is equal to how many ounces? So if you ever pay attention to, if you used to, buy a gallon of milk, right? Or a gallon of water, a gallon of juice, whatever, right? 1 gallon is equal to 128 fluid ounces. That's something to memorize, all right? So 1 gallon, replace the word gallon with the number 1. Replace the word ounce with, or the abbreviation for ounce, with the number 128. Because the relationship between gallons and ounces, these are equal values, right? Right? So now in the other fraction, our second fraction, which is this right here, we're going to replace these abbreviations with numbers also. Except in this case, I don't know how many ounces this is. We about to figure that out. So this ounce gets replaced with, I'm going to use Y. I'm going to use the variable Y because we already used X. I like X, but I already used X. So I'm going to use Y now. Now the gallons is 0.025. 0.025. Right? So that's how many gallons we got. So this many gallons is equal to this many ounces, which we're about to figure out. This many gallons is equal to this many ounces. So 1 over 128 is equal to 0.025 over Y. All right? Now, it's a rhythm. Math is a rhythm. You got to catch the rhythm of math. Once you catch the rhythm, then the problems get easy. But you got to learn how to do the steps. So if you know that we did the cross product property up here, you see we're going to do the cross product property again. That's the rhythm. We just keep doing the same steps over and over again. Even when the numbers change, we do the same steps. All right? Just like with a dance. All right? Just like with a dance, we do the same steps over and over again. All right? So now we're going to cross product. We're going to go like this. We're going to go diagonal. When I say cross, I mean diagonal. So 1 times y, or y times 1 is just y. And what this step does is it simplifies the equation and gets rid of the fractions. And then we're going to do 128 times 0.025. So y is already isolated by itself. It's different from how this problem is set up. Y is already isolated. So all I got to do now is just do this multiplication right here. Get my product of 128 and 0.025. And go back to my calculator. All right. I still got 0.025 still on the display from the last part when I figured this out. Now I'm going to just multiply that by 128. And I get 3.2. So that's 3.2 ounces. So that's how much oil I should use with this ratio, 40-to-1 ratio. If I put a gallon of gas in the tank, you need to mix that with 3.2 ounces of oil. Right? Mathematically, if you follow this. Now, if you don't follow that, then none of this matter. For real, none of this matter. But if you follow this, if you follow the manufacturer recommendations, and the manufacturer indicates that you should have a 40-to-1 ratio between gasoline and oil, then this is how much oil you should have, and this is how you figure out what it is. And don't get intimidated. This ain't that hard. If it doesn't make sense yet, you've never done math like this before, you just need more practice. That's it. You just need more practice, just like with anything in life. Math is no different than any other skill that anybody has. All you have to do is practice. You have to be taught how to do it, and then you got to practice on your own. It's no different. Don't buy into all that false propaganda, thinking that there's a math gene, you got to be born this way, and you got to, don't buy into that. You need solid teaching and practice. You need solid teaching, a conducive learning environment, and a lot of practice. And once you start practicing, you're going to get it. The only time you don't get it is when you stop practicing, or if you didn't have good teaching in the first place. All right? So, yeah, so this is how many ounces. Now, I also said I wanted to take it to the metric system. I wanted to get metric with it, right? So in order to convert the ounces into milliliters, right? We're going to do another proportion where we have, let's do milliliters on top, ounces on the bottom. We could have did ounces on top and milliliters on the bottom. It really don't make a difference. But I just figured, well, I got ounces on the bottom in this drawing up here. I might as well put ounces on the bottom down here too. It really don't make a difference. So I'm going to do milliliters over ounces is equal to milliliters over ounces. Right? And then I got to replace my words with numbers. I got to replace the words with the right numbers. So first off, I need to know the relationship between milliliters and ounces. I need to know that. I need to know the relationship between milliliters and ounces. So I know that the relationship between milliliters and ounces is this. For every 1 ounce is equal to 29.574 milliliters. 1 ounce is equal to 29.574 milliliters. Now, I did another video where I actually used 29.574. But I think for this video, I'm going to switch it up a little bit. I'm going to approximate. I'm going to round it, right, to make the math easier, right? Because 29.574 is almost 30. That's almost 30, right? So instead of writing 29.574, I'm going to round him up to 30. That's 30 milliliters. So we're going to say, because I'm rounding, right? I'm going to approximate to make the math easier, because we can do that sometimes. 1 ounce is the same thing as 30 milliliters. Now, I'm doing that in this video. You might see me in another video where I don't do that, right? But just know, we got options when we do math. So 30 milliliters, we replace the word milliliter with the number 30, is equal to 1 ounce. All right, so we got 30 over 1. And then in the second fraction, what we have is the unknown value that we're looking for. We're trying to figure out how many milliliters is equivalent to this many ounces, 3.2 ounces. So again, we replace the word ounce with the number 3.2. That goes down the bottom. And then the number of milliliters, we don't know. So we pick a variable to represent that temporarily. So let's do Z. We already did X and Y. Let's use Z. All right. Now, we want to solve for Z. That's our goal. Our goal is to solve for Z. It's a few ways we could do this, but like since I've been using the cross product property, I'm gonna continue using the cross product property, right? I'm gonna do 30 times 3.2 and Z times 1. So Z times 1 is just Z. 30 times 3.2 is 30 times 3.2. Z is already isolated by itself on the left side of the equation. So now I got to do 30 times 3.2. I don't need a calculator for that. I know 30 times 3, I'm kind of using the distributive property a little bit because 3.2 really means 3 and 2/10. So that's like doing 30 times 3, which is 90. And then 30 times 0.2. 0.2 is a fifth, right? That's 1/5 because 2/10, 0.2 is 2/10, and 2/10 is the same thing as 1/5, right? So when you do a lot of math, I'm telling you, it's going to become helpful to do a lot of math because you get to learn the equivalencies, right? All the equivalencies. I know that 0.2 is the same thing as 2/10, right? That's how we say it out loud, 2/10, right? If we want to be technical. I know that 2/10 as a fraction, I can reduce that to 1/5. So 0.2 is the same thing as 1/5. So if I'm multiplying 30 times 1/5, I'm taking 1/5 of 30. So a fifth of 30 is 6. So 1/5 of 30 is 6. So that's like 30 divided by 5. All them things that I just said are all interrelated and all equivalent to each other. And it's important to know those relationships so that you can do the math and break the math down. And this is all mental math, right? So you want to be able to do this in the store. You want to be able to do this while when you're driving, if you got to make calculations about, which way you should go, you want to be able to do this on the fly. But it comes with practice though. You got to practice this. And if you got children out there, if you're an adult watching this, and you got children, you want to start your children as early as possible, developing this skill set and developing this fluency as early as possible. So that way they got more time to practice throughout life as they grow up. All right. So 30 times 3 is 90. And then 30 times 0.2 is 6. So we're going to do the 90 plus the 6. 90 plus the 6 is 96. So that's 96 milliliters. Boom. So 3.2 ounces is the same thing as 96 milliliters. All right. That's that. So on this particular bike, if your bike requires a 40 to 1 gas oil ratio requirement, then with 1 gallon of gas, you need to mix that with 3.2 ounces. If you're dealing in ounces, what's that? I think that's the US, not the US, the British imperial system of weights and measurements, right? 3.2 ounces. But if you take it to the metric system, that's 96 milliliters. All right. So either way, and go through these same steps, set up your proportion with words, replace the words with numbers, solve for X or solve for whatever your variable is, cross product property, and then, do whatever you got to do to isolate X by itself. Then if you want to convert from one unit to another, set up another proportion. But you got to know the equivalencies, though. You also got to know the equivalencies. You got to know how many ounces are in a gallon. You got to know how many milliliters are in an ounce if you want to do it this way. All right. So that's that. Just some more dirt bike math for you. And go get some practice. Make up some of your own problems just to practice with this, to get good at it and develop your algebra skills to something that's applicable to something that you deal with if you ride dirt bikes, right? So, whenever you think of algebra, you think of something that you enjoy. You make a connection between algebra or math and something that you enjoy, something that you like, something that you appreciate. All right. That makes it easier to understand, makes it easier to learn. All right. So go get some practice and I'll catch up with you on the next video. Peace.